Good afternoon. Next talk, I will talk about from structured to semantic content authoring. It's going to be the topic in the next 40 minutes. As you can see on the agenda, I also want to include a couple of use cases. That's the second part of my talk. And to start with, I will explain a little bit why and how semantics should or can be embedded in structured content. And since the backbone of all of that are knowledge graphs, the most critical question is how can I create such, and how can I do that in a quite cost-efficient way? So let me introduce, first of all, a little bit where I'm coming from. My name is Andreas Blumauer. I'm the CEO of the Semantic Web company, which is based in Vienna. It's the vendor and producer of a software called PoolParty, which is currently available in version 6. And PoolParty is based on W3C standards. That's already something we have in common with MarkLogic. MarkLogic, which also embraced quite a lot W3C semantic web standards, was quite a natural fit with our technologies. When we became partner 2 years ago, we started to integrate PoolParty with MarkLogic more and more. And one of the reasons standards-based knowledge graphs make a lot of sense is you can reuse a lot of knowledge graphs already available out there, which are either based on RDF schemas, COS, or OWL, or as a combination of all of that. And as you can see on the bottom right, for instance, PoolParty is also able to help you to link your own taxonomies with other graphs like DBpedia or Wikidata, and so on and so forth. So there are tons of data out there you can reuse and enrich your own content with. Couple of facts around the software. So it's a software which is currently available in version 6. The release was just a week ago. That's why I'm telling you that. And the software is something you could install on premise, or it's also available as a cloud service. And I think also important for those companies and organizations using it, you would buy a software and use a software which is again and again developed further. We are working in a very agile market, so things like machine learning are very important, or became very important to us. So therefore, we also do quite a lot of research still in that space, and try to bring in such developments as quickly as possible into the technology stack. So let me talk a little bit about embedded semantics now, from structured to semantic content authoring. So why is that important? My fundamental, or our fundamental assumption is one thing. I think we're going step by step towards engines which help us to find answers to questions. So currently we still stick with this idea of, well, there are documents, and in those documents I hopefully will find finally the facts which are important to make a decision. So, but at the end, it's actually always a linking of several facts, in many, many occasions at least. Many industries live on that. I mean, still there are applications where you're probably happy when you found finally a document that you can go to the lawyer and show it to him or whatever. But in many cases, when it's about gathering facts and developing knowledge around something, for instance, in pharmaceutical industry, you're not interested in documents. At the end, you are interested in a set of facts which make sense all together. So actually, you're retrieving kind of a graph of things which are related to each other and where you can make sense out of it. And that's why we are so interested in semantic technologies. Many of you might come rather from the document-oriented way of structuring information. That's great. I think it's of big value, and I'm not saying that documents will will die. Yeah, there will always be containers to transport information, but they need to be prepared in a different way, structured at the beginning, or at least as quickly as possible, not re-engineered at the very end. So if you produce high-quality structured data or content, you will benefit very quickly from it. So if you look at this high-level architecture, which I call the 4-layered content architecture, you will see that there's a clear distinction made between the metadata layer and the semantic layer. And that's probably that part of this architecture which is kind of innovative or new to a certain degree. Metadata itself, as an asset on top of content, would benefit a lot if you had in addition to that also a semantic layer on top, which describes the meaning of the entities, which are described in the metadata layer, which describe the relations between those. If you introduce not only taxonomies but also ontologies, you can benefit from quality checks you can do on top and things like that. So I'd just like to stress out a semantic layer is not the same as a metadata layer. And the semantic layer should be maintained explicitly as an asset on its own. And it should live independently from the content layer. So it's really more or less the domain knowledge your organization lives from. And one part of this semantic layer would be a taxonomy. So a taxonomy itself is not the semantic layer at all, but it's a backbone of it. And I think this definition made by Joe Pearman of Mecon is very helpful, because a taxonomy described in that way instantly makes a lot of sense. What is it? It's a way to keep track of things that are important to your organization. So it's really a registry of business objects. First of all, that's where the taxonomy can do a great job for you. Secondly, it's a way to keep track of names for those things. You all know that nearly any domain struggles a little bit with Babylonian language confusion. I think that's typically covered by topics like business vocabularies, thesauri, and things like that. And I would say a taxonomy is pretty much the same thing. Yeah, a thesaurus and a taxonomy, I would call it's the same thing. A business vocabulary probably has a slightly different orientation, but still a taxonomy could be exactly the place where you also maintain the names of all those things. And then finally, it's a way to indicate relation between those things. So as an example, on the right-hand side, you see a screenshot of such a taxonomy you might maintain within PoolParty. So now I would like to come up with the question, so how should that embed it in a structured content piece, like DITA, for example? How many of you are familiar with DITA or have already heard about it? Okay, it's around about 50%, okay? 55. Now, DITA is something you might find quite frequently when it comes to technical documentation, for instance. DITA is something, I believe, which will have a very prosperous future in the next couple of years. DITA will be adopted by many organizations, so it was for us, of course, a pretty good candidate to think about how could we embed semantics in DITA and why should we do that. So first of all, if you look at, let's say, two documents here on the left-hand side, that's just ordinary XML. So it's also, with any XML document, you would struggle. First of all, you don't have names for things used consistently. That's one thing you have to re-engineer later in a certain way. We would like to allow authors to use synonyms. A synonym is not a bad thing at all, but all the names, the different names, should refer back to the things. And then, of course, when it comes to new versions, we would like to keep that up to date if names are changed. And then the more exciting stuff happens. So this could be covered by simple Excel sheets, maybe, if you just maintain your synonyms. The more exciting stuff now comes, you can start to include relations between things and the content, where those things occur. You can aggregate chunks of information along the hierarchy very quickly. When you have a taxonomy, you can filter out not only by using a list of names and things, you can really use the hierarchy to aggregate along the hierarchy. And then even more interesting things can be done. You can extract facts from documents. And that's quite a tricky problem already when applying natural language processing in combination with knowledge models, for instance. But I will show you how that could work in a live demo then. And you can do also even automatic quality checks. That's also something which is quite exciting. You could come up with rules and say, okay, in this part of my XML document, I would like to allow only one product name. Or if I use a product name, it should be always named together with the manufacturer. Otherwise, it's not allowed, and stuff like that. So you can really come up with rules to keep your content consistent at the time being written. And I think that's one of the application scenarios where the embedded semantics makes a lot of sense. And last but not least, that brings me back to my initial assumption. It's the more or less that's the precondition which has to be in place, that you are able to give answers to complex questions. And I will show you how that works when you combine a knowledge graph with structured content, and in that case, it's about politicians, which is a very simple example. So let's assume you have a bunch of short biographies of politicians, and now you would like to give answers on complex questions like the ones I've listed on the right-hand side, like which mayors in capital cities of the European Union belong to social democratic parties? Or number 4, maybe, which female mayors belong to a conservative party? And so on. So that's something you might be interested in, and only parts of the answers you would find in the document. Because you need a lot of questions to be answered first before you can answer the actual questions. That's what human beings are very great within, because we are able to link quickly background knowledge with the knowledge we've just extracted in the last couple of minutes. So we always try to contextualize and link the facts from what you've just heard the last 10 minutes or so. You always put into context with your knowledge graph in the background, right? And that's what our engines cannot do yet, really. But potentially they can do it, and I will show you how that works. So what you see here, you need to answer, for instance, which mayors in capital cities and so on. You need to know which city is a capital city. You need to know which city belongs to which country belongs to the European Union, and which of all those parties, and they all have fancy names in our days, are social democratic parties. Yeah. So this background knowledge you wouldn't find in the documents. So you need to maintain that knowledge base somewhere else. And it has to be maintained in a way that you can quickly link it to the facts you can derive from the documents in the current situation. And that's those tricky things you have to do all together. Okay, so I will come up with a solution approach. I'm not saying we are completely there yet. We can do that totally automatically and it works instantly. But I'll show you how that could work. So first step is we have to link all those structured content pieces in a way that's very accurate. So obviously we need to find links between, for instance, in the left-hand side you find SPD, the Social Democratic Party of Germany. On the right-hand side you find it written in a different way, the schema is different. We all know that. That's a typical problem. So obviously we need a very accurate way to bring all that together. One way to do so is using a taxonomy in the background, which elaborates on all the different names, and then you can exchange the literals by the entities, replace it by the URIs, and build triples out of that. That's somehow visualized in the middle of my slide, and on the bottom it visualizes all the triples in a user-friendly way. So that's a typical graph visualization of all those triples. Okay, that's step number one. Another second step has to be done. I have to link that graph I extracted from my XML repositories with the background knowledge. And here a very important assumption takes place. I don't want to maintain this background knowledge per application. I want to keep that separate from the application-centered knowledge graph. And that's typically where MarkLogic could do a great job. You can put there all the, let's say, ground truths of your domain, of your business in this store, and then again and again link those graphs. Are you familiar with the concept of a named graph? In MarkLogic, you can store triples in named graphs. So you can say, okay, this is my geographical knowledge graph probably. And I put that in a named graph and keep it there forever. And I can use that in many different applications later. I only have to make sure that in my domain-specific or application-specific graph, I have to make a link out of it, and that's done via the URIs I'm using. The URIs, of course, should be permanent. They should be used over and over again throughout the organizational boundaries. And therefore, again, you could use geonames. Geonames is even worldwide used, and any geographical entity you could think of, even the smallest village somewhere in Tibet, you will find in geonames, and it has a URI, and you can reuse that. You don't have to reinvent the wheel here. So in that case, I pulled in information from DBpedia. That's the semantic sister of Wikipedia, and here I find, for instance, how many inhabitants Berlin has. And that brings me into the position to give an answer on the one question I had before, which major cities with more than 500,000 inhabitants, and so on. I don't have to make that fact manually available. I just pull it in. And that's something PoolParty can do very nicely for you. You just link your Berlin to the Berlin on DBpedia, and the rest, all the triples, you get automatically for free. And here on the left-hand side, I can state things like Berlin is major city, it's the capital city of Germany, and Germany is part of the European Union. I will give you a live demo of that in a second, but before, I really would like to stress out the fact not any triple you're creating will be done manually. It will be even the smaller portion. The larger portion of the triples and the facts and the semantic graph you're creating, that will be done pretty automatically. And there are a couple of ways to do so. So obviously with PoolParty, the Zoro server, you have an interface where you can work on that rather manually. That's true. But you can import a lot of data. You can import Excel sheets. That's a typical way organizations have started to create things like simple knowledge graphs, simple knowledge models in a way, hierarchies. Okay, that's always a good way to start with. In the box on the right-hand side on the top, the PoolParty Unified Views component is a good way to fetch a lot of data you have in your relational database maybe already. And you want to transform that quickly into RDF. It's kind of an ETL tool for RDF. So just plug into your Oracle database and transform it into RDF and put it into MarkLogic. That's one way. Power tagging, yet another component. Just push through your PowerPoint presentations or Word documents or any other unstructured stuff, and it will make it available in a more structured way. It will find all the entities and again transform it into RDF, again push it into MarkLogic. And then this automatic way to analyze large text corpora is also quite helpful. It generates automatically a graph, which is semi-knowledge graph, I would say, because it's a statistical model of your language. It will detect co-occurrences and relations between concepts, which you have already stated in your knowledge graph, and also other things, terms. We call them terms. A term is not a concept yet, it's not in a graph, but it might have the ability to be part of it. So it can become part of the knowledge graph sooner or later. So that's analyzed based on a reference corpus. Again, it's going to be stored as part of your semantic layer and knowledge graph, all encoded in RDF. And here we see that mechanism. So on the bottom right, this Corpus Learning module is somehow this module which helps you to extend your knowledge graph step by step, semi-automatically. It's a supervised learning system. We are strong believers in a combination between human intelligence and machine learning. We are not believers in machine learning only. We don't think that produces good quality, but as a combined approach, it makes a lot of sense. So now I will step in the live demo. Make that a little bit bigger. Yeah. So here we have this small knowledge graph I was talking about before. So here we have people, politicians, places like Europe, European Union. So you see in that case United Kingdom already is out of the European Union. I will bring it in now in a second and I will show you the difference. So for instance, if I go now to the Sparkle Query Console of MarkLogic, how many of you have worked with the Sparkle Query Console of MarkLogic yet? Well, that's 30% only. Okay. So for those who are not that technical, don't be worried. You can put a very nice user interface on top and nobody will ever see those queries. But still, it's kind of interesting how that works. So what is exciting about Sparkle 1.1 is, to my opinion, especially this little asterisk here. So this little asterisk, it's it's actually exploiting the graph structure and is traversing the graph along certain property paths, and you can do that recursively. So in that case, I'm going to traverse the whole hierarchy of things in my knowledge graph with this little asterisk. And with SQL queries, a lot of joins, and you avoid that. So it's a pretty neat query. I'm just executing that now. And that's the mayors in capital cities which belong to a social democratic party. And I'm now bringing back the United Kingdom into the European Union, and with PoolParty you can do that with one drag and drop. That's very easy actually. Okay, so what PoolParty 6.0 again is now providing is a so-called semantic middleware configurator. So you can really establish your environment, and here that's where MarkLogic is connected. So you see there's a green dot, and now I'm going to push that into my MarkLogic store. You can do that automatically, of course, but here it's done with the user interface. And now I rerun that, and now Sadiq Khan is also in it. So, because, yeah. Okay, so let's take a look maybe also on this corpus analysis here. One thing which it does instantly is it suggests terms which might become candidates for the knowledge graph, and it also says where it belongs to, most probably. Let's take a look on the politicians' short biographies. Let's go for Anne Hidalgo, maybe. She's the mayor of Paris. So you see there's a lot of things extracted. First of all, the concepts. So those are from the knowledge graph, and there's some relevancy here. You can use that now as kind of effect extraction, because in the ontology we've stated that persons could be part of a belief system, or they could be member of a political party, they have a profession and things like that. So if the structured content allows for effect extraction based on ontologies and entities only, then you can even avoid very sophisticated natural language processing. which makes this process much quicker then. So this is part of where you can extract triples in a sense. And here we also extract so-called shadow concepts, concepts not in the biography but somehow still related, and terms which might be somehow interesting to be included in the knowledge graph. Of course, you need a lot of documents that the statistics is valid. You see here there's a red signal, not enough data. Okay, but in principle, I think it's clear. Now I come to the point, so how is PoolParty integrated with MarkLogic? I think you've seen already one of those integration points. Any taxonomy and ontology you create with PoolParty can instantly used in MarkLogic. And the second most important integration point is when you do entity extraction from content, anything will be delivered as an RDF triple and also pushed into the MarkLogic store, yet in another graph. So those two components all together, you can quite easily say that's a full semantic stack. At least we claim that PoolParty is the most complete semantic middleware on the global market. You can check it. And you see the middleware is sitting on top of MarkLogic. And you need both in order to build out a semantic application. So that's how it works at one picture, high level. So you see here, MarkLogic consumes a lot of data, the extracted entities, the ontologies, the taxonomies, and what I also like to mention is unified views. So this is the component where you can do this ETL RDF transformation and push it into MarkLogic as well. So you end a highly consistent knowledge graph, and since MarkLogic is a multi-model database, of course, not anything has to be stored as a triple. So with MarkLogic, you can ingest JSON, XML, unstructured documents and stuff. So you would not store that in the triple layer of MarkLogic, of course. Think about this four-layered content architecture I showed before. Content itself stays where it is, but on top you have the semantic layer and the links between the content and the semantic layer, also known as metadata. And then on top you have analytics and search engines and stuff like that. I will show another example in a second. And this architecture, I think, is also quite interesting because it clearly shows what happens if you free your data out of, or get your data out of your data silos. A typical scenario in our days is people suffer from data silos. SharePoint is one of those, I would say. Search is okay, could be better. But still, most companies, they have a lot of data, not only in SharePoint, and they would like to link that to other repositories. So there's this application server, which builds the link between the PoolParty server and the SharePoint environment and Office 365. It pushes back all the found entities in the SharePoint index. But it also pushes the triples into MarkLogic, potentially, if you want that. Which means you've got all the semantics and the metadata of your SharePoint environment in MarkLogic. And what you can do also now, and that's what I tried to explain before, you can then add the semantic layer on top. In the pharmaceutical industry, which here is visualized, could be things like UniProt or Reactome or gene ontology or whatever. And with PoolParty, you do the links between the knowledge graphs, the taxonomies, and the found entities in your SharePoint or whatever environment. And then all together in MarkLogic, you can start to create quite interesting analytics dashboards on top using things like Tableau or KNIME or D360. You could also use another standard component of our software, which is the PoolParty Graph Search, which also can sit on top of MarkLogic. So now I would like to, I think I have around about 5 minutes left. Is that correct? Yeah. Talk a little bit about additional use cases. I think we already have seen that one, question answering, and and graph-based search with MarkLogic. So that's one use case we currently see a lot of interest on the market. More and more companies just don't want to search for documents only. They want to get a system which can understand natural language queries in a way, translate them back into the knowledge graph, and then executes a Sparkle query and finds the answers to a certain question. Another demo I'd like to show you quickly is the semantic search over World Bank documents. That's basically using the architecture where PoolParty and MarkLogic are integrated with each other. That means we ingested XML documents from the World Bank. We classified them with 2 taxonomies in that case, which are geolocations and the World Bank topical taxonomy, which is available on the web as open data, by the way. So they provide a linked open data version of it based on PoolParty. And here you get the results. So still documents. If you click on maybe Europe as a facet, you will see that it's not just filtering out documents. It also exposes information around the search concept. In that case, Europe. You can configure that to your own needs. Here in that case, you see an image, a description, maybe a link, whatever you like. So that's one feature when using RDF together with the document index. You can, like Google does, on the right-hand side, you always see some basic information around the search concept. In the middle, you've got the actual documents. Well, if I pick one, like this one about Ukraine and gas supply something, one nice feature here is similarity to other documents. So that's quite enhanced the out-of-the-box similarity feature of MarkLogic when you use it all together with a knowledge graph. In the background, it produces higher accuracy. I mean, it's kind of a no-brainer. And then the World Bank topics graph, again, you will see all the extracted and found entities. So that's quite useful. You see quickly what this maybe very long document is all about, and also geographic regions. So you can put several extractors in series if you like. And then another use case I'd like to come up with is an application which was or is in use at Wolters Kluwer, the large publisher in the legal domain. And I like this approach very much because it also shows it's not anymore about just documents and unstructured information. Also at Wolters Kluwer, of course, the content is highly structured from the very beginning, because later it's not only about guide me before searching, but also guide me after searching and guide me in the document. And a precondition to do so really is to have embedded semantics in a structured content piece. And again, the solution for that is that there's a knowledge graph, kind of an intermediary between a question the user has and the semi-structured content on the other hand side, where the answer potentially can be found. And one thing Wolters did was there's kind of a set of potential questions in that certain domain. You would not expect any kind of question, but rather typical question like how high is the percentage of my tax reduction if my vehicle has la la la. So that's types of questions, and those of course are somehow reflected by the documents, by the document structure and the knowledge graph. That's clear. And so you see that here, for instance, you've got, when you do the content authoring, you've got a predefined structure, and all these elements then can be connected, as you can see here, with concepts from the knowledge graph. So in that case, it's done by the PoolParty extractor semi-automatically. System suggests potential links to the knowledge graph, and the author can then decide which ones should be used and which not. And by that, later, you can quickly link little fragments of your XML document to a concrete question. So it's very close to a question answering engine already. And last but not least, I'd like to come up with another demo, which is about font to XML and the way it uses semantics in it. So I've got here XML document. Font to XML is a product created by one of our partners, a company called Lyonnaise based in the Netherlands. And this product is a great way to create XML documents without a lot of XML knowledge. And that's something people deserve in our days. You would not like to be confronted again and again with all the complexity. So here, for instance, a little data document which explains how to get rid of a cold. For instance, you could increase your vitamins, and now I'm putting in something like don't take antibiotics, rather go to sleep. And you see the system recognizes things automatically. And if I click on it, right-click in that case, it will look up in the knowledge graph and come up with suggestions. Either you could even refine it, you could use a different name, and most of all, it replaces this literal by the thing represented by the uniform resource identifier, the URI. And now you've got a nice data structure. You can do very fine-grained queries over your data or XML documents in general. You can find this, show me all diseases where a cure is recommended, where antibiotics are not recommended properly. So that could be a question. So I can do that right now. I can say I replace and refer to antibacterial agents instead of antibiotics. And now you've got exactly that replaced with the corresponding URI. If I click on maybe vitamins, I also get a definition again. You can configure that in principle however you like. So you get a lot of support as a content author. And that's a great thing. So I will come to an end. Outlook. Actually, the whole content lifecycle can benefit from semantics. Yeah, it's not necessarily at the very end you do semantic reengineering. You could come up with semantics at the very beginning, which is content creation. Two integration scenarios. Most people in our days think about semantics just being embedded in a content management system as kind of a little bit better metadata. But what it really should be, a semantic layer on top of all your content repositories, maintained and stored in a dedicated storage layer, most probably MarkLogic. And last but not least, if you're interested in learning a little bit more about semantics, I'd like to encourage you to visit the PoolParty Academy. It's an e-learning, self-paced training and certification course, and the first track is for free. And you can also try it out. Thanks a lot.
Thank you. We have time for one or two questions. Does anybody have any? No? No questions? Oh, there we go.
Thank you.
So you link to a wonderful external ontology, and that ontology is no longer maintained by the organization that published it. What does PoolParty do?
I mean, first of all, there should be a signal that it's not maintained. And the second part, even if it's not maintained anymore, it might still make a lot of sense. I mean, there are good examples like friend of a friend ontology. It's been out for many years, and it still is. It's a valid ontology. I mean, it still makes sense if you include it in your knowledge graphs. So expect what you might refer to is, I mean, if let's say some parts are outdated, really, if they're not valid anymore, or even wrong. So one way to find that out semi-automatically is to do this corpus analysis, because if you have a lot of incoming documents where you find out that, let's say, a certain name cannot be found anymore, or it's connotated in a different way. If you find out Barack Obama is not found with White House together anymore, then probably the relation doesn't make sense anymore and things like that. So you can do that quite semi-automatically in a way. And we always encourage, of course, customers to let the machine learning and corpus learning modules do that job for them. Other parts, I mean, we have to specify what do you mean exactly by the ontology is not valid anymore.
Any more questions? Okay, please can I just remind you to take some time to do feedback in your app, and if you can all make your way back down to the ground floor to the main room for the last sessions. Thank you.